we're going to have a look at the hydrogen electrode. So here we have a boiling tube with the hydrogen electrode. So we have a hydrogen cylinder here, which is bubbling hydrogen gas down through that central little glass tube in over the platinum electrode, which is the black square you can just see there. Now the liquid inside the boiling tube is 1 mole per dm cubed hydrochloric acid. So in theory, in this hydrogen electrode at present we have hydrogen gas at 1 atmosphere and we have hydrogen ions at a concentration of 1 mole per dm cubed. Okay, then we have the salt bridge, which is the filter paper running between the two solutions. Okay, the salt bridge has been soaked in saturated potassium nitrate solution. And then we have the other half cell, which is the beaker with copper sulfate solution, 1 mole per dm cubed copper sulfate solution, and some copper metal. Now if I attach the electrode to the copper metal, hopefully a current will flow. And we have a reading on the voltmeter of about, what's that say, 0.33 volts. Positive 0.33 volts. Now it's supposed to be 0.34, but actually that's not bad for this setup. I'm pretty pleased with that. Okay, I've reset the system. So I've replaced the salt bridge and I've changed the half cell from a copper half cell to a zinc half cell. So I now have 1 mole per dm cubed solution of zinc sulfate, and I've replaced the metal electrode from copper to zinc, so I have a zinc electrode, and the voltage now reads minus 0.68 volts. So the electrons are travelling in the opposite direction to that which they are travelling the first time. Okay, another setup now. This time we have silver nitrate solution, and the electrode is made from silver foil. Now notice how it's 0.5 mole per dm cubed silver nitrate solution. We don't quite stretch to making 1 mole per dm cubed silver solution, but we have a half cell of silver ions and a silver metal, and now the voltage is 0.78 volts. Now we have a new half cell. We have a magnesium half cell, so we have 1 mole per dm cubed magnesium sulfate, and we have some magnesium metal as the electrode. Again, notice what the reading is this time. Again, it's a negative reading, so the electrons are flowing in the opposite direction to those of copper and silver. So here we have a voltaic cell made up of a zinc half cell and a copper half cell. So we have 1 mole per dm cubed zinc solution and a zinc metal electrode. We have a 1 mole per dm cubed copper solution and a copper electrode. Right, make a note of the voltmeter reading and compare it to the difference between the hydrogen electrode readings for the zinc half cell and the copper half cell. Okay, in this setup we now have magnesium sulfate and magnesium for 1 half cell, and silver nitrate and silver for the other half cell, with a salt bridge of saturated potassium nitrate. Okay, make a note of the voltage reading and notice how the magnesium has formed the negative electrode and the silver half cell has formed the positive electrode. So here we have a zinc and silver voltaic cell. So a half cell with zinc ions and a zinc electrode, and a half cell with silver ions and a silver electrode. So here we have a magnesium half cell and a copper half cell. We have 1 mole per dm cubed magnesium ions and magnesium metal, and 1 mole per dm cubed copper ions and copper metal, and a salt bridge made from filter paper and potassium nitrate solution. So here we have a voltaic cell made up of a magnesium half cell and a zinc half cell. So we have magnesium sulfate and a magnesium metal, zinc sulfate and zinc metal. Make a note of the voltage. Here we have a copper and silver voltaic cell. So a half cell of copper ions and a copper electrode, and a half cell of silver ions and a silver electrode.